Okay, more examples about relative velocity. Let us start with this one. The velocity of K relative to L is this, and the velocity of L is this. Find the true velocity of K. So they are giving us, first of all, we summarize. K relative to L, that is K relative to L, they are giving it as 4 negative 5. Then the velocity of L is negative 1, 2. Then they are asking us to get the true velocity of K. They want us to get the velocity of K. So we first start this. So K relative to L is given by velocity of K minus velocity of L. So you see we want this, so I take this side. So this would be 4 negative 5 equaling to velocity of K minus velocity of L, which is negative 1, 2. So when I take it this side, you can every side be added 4, negative 5, then minus negative 1, 2. This will give me the velocity of K. And from there, when you simplify our velocity of K, is going to be 4 minus minus, give me a 5, negative 5 minus 2, that would be negative 7 meters per second. So now my velocity of K is 5I minus 7 meters per second, as simple as that. Meters per second, then add that also. Okay, part B, they are giving us that the velocity, or now here they are giving us the magnitude of the velocities plus their direction in terms of angles. So the velocity of A is 20 meters per second on a bearing of 0, 30 degrees. So from there, we not always our bearings are given the 3 units form. That's why here it's supposed to be 0, 30 degrees. So now we start with the A. Our A, this is my A. The north line. Then this one, I telling us that it's 20 meters per second. Okay, so then we need to get the velocity of A. How are we getting the velocity of A? We resolve this velocity here. This is our north line or else. So to get this, we shall move either like this, and then this, or like this, and then this. It's up to you. So if you move like this, then we can get this. If you have this arm, but now they are giving us this arm. So the best way is to move like this, then like this. Okay. I think you can see. So based on the angle they are giving you always. So this one would be if they are giving you, if you have that angle there. So now, because they are giving me this angle as 30 degrees, then I can move up, then I move to this. So I'm going to move up, then I move this. In simple terms, I'm resolving that velocity. So instead, this one is opposite. This one is adjacent and this one is opposite. So this one is going to be 20. Opposite goes with line 30 degrees from the idea of so. Opposite goes with sign. So that's why you see here you have sign. And then this is going to be our adjacent, which you can see is going to be 20 cos 30 degrees. So meaning that now my velocity of A is going to be giving me, we give the x component, then the y component. And from there, I'll be having my x component, the x component is the direction where it's taking. Terms are like this because the result, our is like this, so this one is half term, and then they meet there. So see it's going in a positive, so that's why I have 20 sine 30 degrees. Then this one is also going in positive, so it's 20 cos 30 degrees. So when you have that, you can easily simplify this to, you see sine of 30 is a half. So this will give us, okay, 20 into a half. Then 20 into root 3 over 2. So our velocity of A is going to be 10. Then this will give us 10 root 3 meters per second. Okay, after getting the velocity of A, then I come to B. B is moving on a bearing of this. So if I put my bearing, okay, this is the north line, so the bearing of 150 is there. So this is going to be my B moving at 40 meters per second. So if the whole of this is 150, in order from here up to here is 90, so meaning this balance from here, it will be just 60. So meaning we can resolve also this one. How are you going to resolve? You see, this is what we have. So now, to resolve this, we move like this, then we shall come down to it like that, in that order. Or you can get this as that and then resolve like this. It's up to you. All of them will be giving you the same answer. So this is adjacent. Adjacent goes with the cos, so it's going to be 40 cos 60 degrees. Then this is going to give us, you see, it's opposite this angle, so it will be 40 sine 60 degrees. Okay, so from there, you see that my velocity of B is going to be Vx, the component in y. So the x component is it's going to be 40 cos 60 degrees. Then the y component is it's going in the negative, so this one is going to be now negative 40 sine 60 degrees. So from there, I can simplify this to, this is going to be 40, cos of 60 is a half. Then negative 40, sine of 60 is root 3 over 2. These are special angles. So sine of 60, already it's root 3 over 2. Then cos of 60, already it's a half. Yet here, the sine of 30 is going to be a half, but for the cos of 30, it's going to be root 3 over 2. These are special angles. So from there, my velocity of B is going to be 20. It's going to be 20, then minus 20 root 3 meters per second with ease. Then they want us to find the velocity of B relative to A. So velocity of B relative to A. So it's given by velocity of B minus velocity of A. So can you substitute? Substituting in there, the velocity of B is 20 minus 20 root 3. Then minus velocity of A, which is 10. Minus 10 root 3. And so our B relative to A is going to be 20 minus 10, that will give us 10. Then negative 20 minus 10, that will give us negative 30 root 3 meters per second. So after getting this, because we want that velocity, so you get the magnitude of this, and then it's the direction, because the velocity is given by the magnitude and then the direction. So magnitude of B relative to A will be the square root of 10 squared, then plus negative 30 root 3 squared. So this will give us give us 52.915 Then in there, we can also get now the direction. So our direction, you can get now our alpha is going to be tan inverse of this over that. Okay, if you have sketched that, you can see this is going to be, if we have, this is positive, this is negative. So see this one is 10, the x, and this is 30, root 3. So this is going to be my velocity of B relative to A. So if I want now this, it can change. If I want this angle here, I can say now, if I want the opposite is going to be 10 over the adjacent, which is going to be that. So that's changing. If you get that at once. Because here we give our angles the bearing from the north line or the south line. So that if I want this angle specifically, I get the opposite over the adjacent. So my opposite is going to be this, so this is going to be the opposite, so 10 over 30 to 3. And so there, my alpha will be 10.890. So the direction is going to be south, 10.89 towards the west. How? Because it's this one, it's south towards the east. So that's the east, not the west. Towards the east. Because you see, from here we measure 10, this is the alpha, 10, but this we are going towards the east. So that's how we handle that. I wish you well.